Okay, welcome back everyone. Today we're moving on to our next section, which is lesson 7. We're still in chapter 1. And guess what? We will be solving one-step equations by using addition and subtraction. Let's hear our objective.
All right, just like you just put down in your table of contents, your objective for today is you will be able to solve equations using addition and subtraction.
Our first job here is going to take down some vocabulary and just get to know what is with us when we're solving equations. So our first question is, well, what is an equation? The definition is an equation is a mathematical sentence that uses an equal sign, so in your blank write equal sign, to show that two expressions have the same value. So an example that we could put down, and we're not going to see variables yet just in this that I'm going to show you an example, but for something like this, if I had 5 plus 3 is equal to the same thing as 7 plus 1. Because 5 plus 3 we know is 8 and 7 plus 1 is also 8. So it's showing that two expressions have the same value. Okay, now when we solve equations, we are going to see the variable appear, and we actually are trying to get the variable alone. So that's really our goal right here is what you see. So let me reread it. It says, your goal when solving equations is to always get the variable alone on one side of the equation. The value on the other side tells you the solution to the equation. Another vocabulary word that we're going to talk about in class is this word inverse operations. And that's actually what we do to get the variable alone. So in other words, we use inverse operations, or what we call the undo operation, to get the variable alone on one side of the equation. So let me tell you a little bit about what operations undo each other. So I'm going to write above here. Well, today we're going to just be seeing addition and subtraction. So addition and subtraction undo each other. So that means if I wanted to add 5 to something, the undo of that would be then to subtract 5. So addition and subtraction undo each other. And then also we have multiplication and division, and those operations undo each other. So if we multiplied something by 3, to undo the multiplication of 3, we would divide to get that 3 away. So multiplication and division, that should say division, undo each other. And then one that we're going to get to later on in this year is square rooting numbers. And just so we can just get to know it a little bit, and we're not seeing it yet in this lesson, but if you didn't know, if we square a number, so if I did like 2 squared, we know that that's 4. To get back, I would square root 4 and we would get 2. So we can say that squares and square roots undo each other as well. All right, take those notes down and we'll now start solving equations.
All right, our next step is to practice solving some one-step equations with addition and subtraction. So if you read here at the top, it says when we solve equations, we will separate the equal sign with 2 lines so that we can find our variable easily and know which operation to use in order to undo the operation given in the problem. And so if you look here, you see that we've repeated the same problem 3 times, and so we're going to step by step take you through what we call the railroad method to solving equations. And this is a method we will expect you to use to solve your equations and show your work. So the example says x plus 7 is equal to 11. First thing I'm going to do is I'm going to draw my lines. Okay, so that's what makes it look like a railroad, is because as you move down and solve, you're going to end up having equal signs there in between your 2 lines, and it looks like a railroad track. Okay, so then these aren't in your notes, so if you want to put that in there, you probably should, so that you know that the step-by-step. Then the next step says to undo the positive 7 by subtracting 7 from both sides. So I'm going to go ahead and draw my railroad tracks, which we've already done. And then I'm going to look here. And we also like to think of this as a cover-up method. If I cover up, and I know it's not really covering it up, but if I cover up my variable, then you can see that what I want to get rid of here is this plus 7. That's what I have to get away from the x, or away from the variable, so that the variable is by itself. And so that's why this is a positive 7. I'm going to subtract 7 from both sides. And so that's my first step there. And then you look over here at the third time we wrote the problem, x plus 7 equals 11. Put my railroad tracks in there. And I've subtracted 7 from both sides. And then what do you get once you subtract that 7 from both sides? Well, look what happens here. A positive 7 and a negative 7, those are called inverse operations, and they equal a 0. So what I'm left with is x plus 0 is equal to, and what is 11 minus 7? Hopefully you said 4. So there you can see that's kind of where this step came in right here. You should get x plus 0 on one side, and we did. It's right there. And so when I then think about this problem and what is x equal to, I don't have to put this 0 in here. That's just kind of a placeholder that shows us we've done the right step. So what I end up with is simply x equals 4. Now, even more important than getting x equals 4 is to check and make sure that 4 works. So now I'm going to switch colors. I'm going to look up here, and if x is 4, then 4 plus 7 should equal 11. And does 4 plus 7 equal 11? Yes. So we know we've gotten the right value for x.
All right, here we go with practicing solving equations, and we are going to solve our equation and show our work by using the railroad method. So the first step to that is to draw the lines on the equal sign so that you are separating the two sides of the equation that we see. And then next, think about what needs to get the variable alone. So we have our little box here that we have that we can cover the variable up so we can see that it's tied up right now with a value of 6. Now, 6 doesn't have a negative sign on it, so that means I shouldn't add 6 to both sides. It's just kind of realizing that 6 is present there. So to undo the 6, what operation do you think? Hopefully you said subtraction, so we're going to undo that by subtracting 6 to both sides. And it's really important that you stay consistent to subtract 6 to both sides of the equation, not just to one side, because we need to see it get out of both sides. So now we have 6 minus 6, which is 0. Drop down your plus sign, drop down t, drop down your equal sign, and then solve the math. What is 28 minus 6? Which is 22. And then we can just rewrite that t equals 22. The last step that we want to do is make sure that that is actually correct. So we can resubstitute 22 in for t into back the equation and rewrite it and see if we get 28 on both sides. So I'm going to rewrite it below. So you have 6 plus 22 now for t. Is that equal to, and I'm going to do a little mini question mark above it, is that equal to 28? And yes, because 6 plus 22 is 28, so we got the same thing. We got our equation to be equal. Here we go with our next equation. So it reads negative 14 equals m plus 8. First step, draw the lines down the equal sign. Second step is we're going to find what inverse operation we should use to get the variable alone. So if we covered up m, hopefully you realize right now, or you can visually see that you see a plus 8. So the undo, what do you think? What would undo that? Hopefully you're thinking subtraction. So we want to subtract 8 from both sides. And then another way to visually show that you get 0 is to just maybe make a line through positive 8 and negative 8, or plus 8 minus 8 gives you 0, leaving you with m alone on the right side of the equation. And then we have the math expression of negative 14 minus 8. Now, integers are not going to go away for us, so we have to think back to doing keep, change, change. That means you're going to keep negative 14 the same, change your addition, change your subtraction sign to addition, and change 8 to its opposite. So then it reads negative 14 plus negative 8, which gives you a negative 22. Now let's always just mentally check that to make sure that that's right. So down below I'm going to resubstitute in. So I'm rewriting the problem. Negative 14 equals, is that equal to negative 22 plus 8? And yes, negative 22 plus 8 is negative 14. So again, we are right with the correct value that m is equal to negative 22. Okay, here we go with our last example on this page. Again, we're first going to start by separating the equation, so drawing the railroad lines. Then think about what operation is going to undo the number that's tied up with the variable. So this one's a little bit starting to get special with some of our integers, and it says plus a negative 14. Which really means that you're trying to get 0 on that side. So when I cover this up, you're trying to create 0 with negative 14. That means that you should add 14 to both sides so that you're getting 0 on one side. So the inverse is adding 14. That leaves you now with W alone on the right side, and then we have 15 plus 14, which gives us a final answer of 29. Now we just want to make sure that that's right, so we're going to resubstitute in 29 for W. So we have 15 equals, or we're really asking ourselves that question, does 15 equal the same thing as 29 plus a negative 14? And yes, 29 plus negative 14 gives you an answer 15, so 15 is equal to 15.
All right, now we're going to look at some examples involving subtraction. So you see here in our first example, we have m minus 5 is equal to a negative 7. So the first step is to draw our railroad tracks. And then the second step is to think about, okay, what if I cover up my variable? We're just going to pretend that's covered up. What do I need to do to both sides to get that m by itself? And so hopefully you're looking at this negative 5 right here and asking yourself, what would I add to negative 5 to get 0? And the answer is a positive 5. So that's my next step. And then when I add that positive 5 to both sides, the negative 5 plus 5 gives me 0, but I still have the m. So now I have m plus 0 is equal to, and I have negative 7 plus 5. Think about integer chips. You can think about a number line. We're starting at a negative 7, and we're adding 5 to that, so we get a negative 2. Then I can take out that plus 0 because it really means nothing, and m is equal to a negative 2. On the previous slide with Ms. Heimler, you actually wrote out checking to make sure that your value works. We're just going to verbally go through it on these examples. So if m is equal to negative 2, let's plug that in. So negative 2 minus 5. So think about your number line. You're starting at negative 2. You're taking away 5 more, and you are going to end up at negative 7. So this one is check and correct. All right, moving on to the next example, we have 14 equals m minus 8. So again, I'm going to cover up my variable. I'm going to cover up my m there, and I'm going to make my railroad tracks. And then I'm going to think about, okay, so I have a negative 8 over here, m minus 8, and what do I have to add to negative 8 to get to 0? And hopefully you're thinking a positive 8. Now notice that my variable is first in this one and that we've kind of switched sides of the equal sign. Notice it's not making a difference in my steps that I take to solve this. So I put my plus 8 right underneath my minus 8 because then I can see that a negative 8 plus 8 does indeed give me 0. So now I have m plus 0 is equal to, and 14 plus 8, both positive integers, and that gives me 22. So I can get rid of the plus 0, and 22 is equal to m. Now some of you may be thinking we need to flip-flop that. That's not the case. We want to leave it exactly how we solved it. The equal sign means that both sides are equivalent to each other or mean the same thing. So it doesn't matter if the variable is on one side and the number is on the other side. And then of course, I'm going to go back and I'm going to check, does 22 work? So I'm going to plug in 22. 22 minus 8 does give me 14. So my answer works. All right, our last problem says negative 10 equals w minus a negative 13. So again, I'm going to cover up the variable, only this time I have to be really careful because you can see here that we have a double negative. And so when we have a double negative, let's go ahead and do the keep, change, change. That's going to show us or help us to make sure that we don't make some simple mistakes. So when I keep, change, change, w stays the way it is, my subtraction becomes addition, and my negative 13 becomes a positive 13. And so you can see here what I really have is negative 10. And you know what? I'll just go ahead and rewrite it. I have negative 10 equals w plus 13. So now I'm back to an addition problem. And I can ask myself now, okay, what do I add to both sides to get w by itself, or what is the opposite of my positive 13? And that is a negative 13. So I'm going to subtract 13 from both sides and keep the 13s together there, and they make 0. So now I have a negative 10 minus 13, which gives me a negative 23, and that is equal to w plus 0. We can get rid of the 0, and negative 23 is equal to w. Last step, double check, make sure that works. And in this one we may want to, I'm just going to go ahead and write this one out. So I have a negative 23 minus a negative 13. And I can do the keep, change, change again. So I have negative 23 plus 13, and that does give me negative 10. So that one checks too.
Okay, our last example is to solve equations when our variable is negative. So our question we're trying to answer is, what happens when the variable is negative? Well, we start them the same way. So we're going to begin with the railroad. Then, looking at our problem, you see that the variable, even though it's negative, it is tied up with the plus 8. So to undo that, we are going to subtract 8 from both sides. And 14 minus 8 gives us 6. Drop down your equal sign. We still have negative q with us, and then those 8s become 0. Now, we can't end our problem with a negative variable, so I'm just going to step aside to tell you what we do. What's our next step? So before we do that, there's a hidden number that's right in front of q, and maybe you can think about what that might be, and I'm going to help us here by saying if I had 2q, then you would see it as a 2 in front. If we had 3q, then you'd see it with a 3 in front. If we had 1q, we would just see q, and we tend not to put the 1s in front because it's kind of a waste of time. You know you have 1q, which is just q. And so that's what you're seeing in front of this q, is there's actually a hidden 1. So write that in for yourself, because that's going to help you figure out what you do to undo that negative 1 there. So right now, this is being multiplied right there. So to undo it, we need to divide. So we're going to divide both sides by a negative 1. And we're left with negative 1 divided by negative 1 is 1, and 1q is just q again. So now we left with our variable as positive, and then 6 divided by negative 1 is negative 6. And then do the mental check. If we did plug that back in for q, would we get the right answer? So it would be a negative 6 plus 8, which negative 6 really becomes the mega plus. So you're doing 6 plus 8 is 14. So you're right. Your answer is negative 6. Let's try this next one. So again, we're going to start with drawing our railroad lines. Cover up the variable. So right now you see the variable is negative b. You have to get 3 out of there. So we need to subtract 3 from both sides. That's going to leave us with those 3's gone, but now we still have negative b. drop down your equal sign. 15 minus 3 is 12. And now add your hidden 1 in front. And then that's being multiplied with b, so you want to divide both sides by -1. And you're left with b equals -12. So steps that, and then check that. When you plug that back in, you would then see it says 3 minus -12, is that equal to 15? And yes, because of keep, change there, so you know you're right. So really, steps that we want to use is that you will need to keep the variable positive always, and then if we end up with a negative variable, you're going to divide away the number that's tied up right next door with the variable. So in this case, if our variable is negative, you will divide away the number that's attached with it. So in this case, it was a -1. So divide away the number -1 away from that variable. It won't always be -1. And once we start getting into the multiplication and division, you'll see how other numbers will attach on with the variables as well. All right, that's it. Go ahead and finish your practice problems, and we'll see you guys in class. Take care.